Hello grade 10s, welcome to the last lesson in this series representing chemical change. In this series we have focused on the skill of balancing chemical equations. In developing this skill, we began this series by looking at the reactions that happen in a blast furnace to extract metals from their ores. We have investigated the reactions of metals and non-metals in oxygen. The reactions of metals with oxygen are examples of redox reactions. In a redox reaction, one reactant loses electrons and the other reactant gains electrons. We have also investigated the reactions of metal and non-metal oxides in water and the reactions of metals in water and acid. Throughout this series, you have had to balance the chemical equations for these different reactions. Let's see how well you can do this. In these two test tubes, I have solutions. In one test tube, there is lead nitrate. In the other, there is some potassium iodide. Now, look at what happens when I pour the solutions from each of these test tubes into a beaker. The yellow substance that forms is lead iodide. All the lead halides are insoluble in water and form precipitates. In a precipitate reaction, the reactants are both soluble in water, which is why they dissolve in water. But when the solutions are mixed, a solid product that does not dissolve in water forms. This solid product is called a precipitate. Let's see if you can balance the chemical equation for this reaction. An aqueous solution of lead nitrate reacts with an aqueous solution to potassium iodide to form a precipitate of lead iodide and potassium nitrate, which remains dissolved in solution. The balanced chemical equation is Pb open brackets NO3 close brackets plus 2Ki reacts to form PbI2 plus 2KNO3. In today's lesson, we will investigate the reactions of the halogens with metals to form metal halides and not only balance the chemical equations but explore what they can tell us. By the end of the lesson, you should be able to write balanced chemical equations for the reactions of metals with the halogens and interpret balanced chemical equations. Can you remember which group of elements are called the halogens? Let's ask Tiasha to refresh your memory.
Today, we are going to focus our experiments on one specific group of nonmetals. The halogens that we find here in group 7 of the periodic table. Let's recap what halogens look like at room temperature. Fluorine is a colorless gas that is very reactive. We cannot use this element in classroom demonstrations because it is too dangerous. Chlorine is a yellow-green gas at room temperature, and bromine is a dark red liquid. Iodine is a shiny purple-black solid that sublimes or evaporates into a gas at low temperatures. Another thing you need to know about halogens is that even as diatomic molecules, these elements are not satisfied. Why keep sharing electrons if you can take an electron from another element, like a metal? Now, when halogens react with metals, new compounds are formed. The halogen is not called a halogen anymore, but it becomes a halide. For the rest of this lesson, we will have a look at the reactions of halogens with metals. John is standing by in the lab to show us 3 different reactions. Let's have a look.
In our first reaction, we're going to react sodium and chlorine. And the next 2, we're going to react zinc and aluminium with iodine. Whenever halogens and metals react, a new compound forms. These compounds are called metal halides. It's important to note that the name of the halogen also changes. So in our first reaction, we expect to form a metal chloride. Now let's get on with the experiment. Here's a gas jar with chlorine gas, and here's some sodium metal, which I'm placing on the combustion spoon. I'm now going to heat the sodium. It will take a while to melt. It's just about ready. Let's have a closer look at the product. some crystals have formed. This is sodium chloride. Now remember, in our next two experiments, we're going to be reacting metals with iodine. These are spectacular reactions that produce lots of billowing smoke that is poisonous. So it needs to be done in a fume cupboard or a well-ventilated area. I've decided to do them outside, so come with me. Right, I've set up our experiment here on the trolley. Come and have a closer look. Here's some iodine crystals, here is zinc powder, and here is the aluminium powder. The first thing I'm going to do is to crush the iodine crystals in the pestle and mortar. I'm now going to add some zinc powder to this mixture and mix it up. Now this reaction doesn't take place immediately at room temperature. We say it is non-spontaneous. We could heat it up using a Bunsen burner, or we could use a chemical, a catalyst. A catalyst is a chemical that speeds up a reaction. In this case, I'm going to use water as the catalyst. Taking some water in a syringe, I'm going to add just a few drops of water onto this mixture. And almost immediately, you can see a reaction is starting. We're getting purple fumes forming. This plate is still warm. Energy in the form of heat was released during this reaction. This means that this type of reaction is called an exothermic reaction. Now let's look at the product. This gray powder here is called zinc iodide. It was the product of the reaction. We also saw purple fumes being released during the reaction. Where did they come from? Well, unreacted iodine sublimed during this reaction. Do you remember what the word sublime means? When a substance changes directly from the solid phase into a gas phase, we say that it sublimes. Now I'm going to do exactly the same sort of reaction, but this time between aluminium and iodine. Watch. I'm going to put the iodine into the pestle and mortar, crush it up. This is even more reactive. Look, there's sparks and flames coming out of here. Quite like a chemical magic show, don't you think? We observed flames being formed in this reaction, so the reaction must be exothermic. We also know that a metal halide was formed. It is a white grayish product called aluminium iodide. You will also have noticed lots of purple fumes. These were, of course, the iodine that was subliming due to the increased temperature. Those are all the experiments we're going to do today. I hope you've taken careful note of the observations and recorded your results.
Thanks, John. These are all examples of redox reactions. Do you think that you can write balanced chemical equations for these experiments? The products formed in each reaction were sodium chloride, zinc 2 iodide, and aluminium iodide. The chemical formula of compounds and molecules are dependent on the rules of chemical bonding. Do you know where these principles come from? Let's ask Tiasha to tell us.
In 1916, a chemist, Gilbert Lewis, came up with a theory. He said that chemical bonds were formed because valence electrons from the atoms interact with each other. Lewis knew about electron orbitals. He realized that atoms like to have their outer energy level completely filled with the maximum number of electrons allowed. Therefore, atoms that don't have complete outer energy levels react with other atoms to transfer or share electrons. In this way, they complete their orbitals. Lewis's theory is the basis of modern ideas about chemical bonding.
The halides have 7 valence electrons, so all the halides need 1 electron to fill their valence shell. Sodium, which is in group 1, has 1 valence electron. So, when sodium reacts with chlorine, 1 sodium atom reacts with 1 chlorine atom, so the chemical formula for sodium chloride is NaCl. Aluminium is in group 3 and has 3 valence electrons to transfer. So 3 iodine atoms react with 1 aluminium atom. The formula for aluminium iodide is Al(I3). Zinc is a transition metal. So the name zinc 2 iodide tells us that 1 zinc atom transfers 2 electrons to iodine. So the chemical formula is ZnI2. Now try to write balanced chemical equations for these 3 reactions. Take a few minutes and then Tiasha will see if you are correct.
Here they are. The first reaction we saw was sodium reacting with chlorine gas. The chemical equation for this reaction is 2Na plus Cl2 react to form 2NaCl. Next was the reaction of zinc and iodine. Here the chemical equation is Zn plus I2 react to form ZnI2. Lastly, we looked at the reaction of aluminium and iodine. The chemical equation for this reaction is 2Al plus 3I2 react to form 2Al(I3).
Thanks, Tiasha. Before we end this lesson, let's look at what a balanced chemical equation actually tells us. Remember that to balance a chemical equation, it is important to understand the law of conservation of matter. This law states that the mass of a closed system of substances will remain constant. Matter can change form, but cannot be created or destroyed. During a chemical reaction, the atoms of the elements in the reactants rearrange to form new substances. And in a chemical reaction, the atoms are conserved. If atoms are conserved, the total mass of the reactants before the reaction must be equal to the total mass of the products after the reaction. Let's look at the balanced chemical equation for the reaction of zinc with iodine. The equation is Zn reacts with I2 to form ZnI2. 1 atom of zinc reacts with 2 atoms of iodine in an iodine molecule. The product formed is zinc iodide. 1 particle of zinc iodide consists of 1 atom of zinc and 2 atoms of iodine. The balanced chemical equation shows us that 1 atom of zinc and 2 atoms of iodine react to form zinc iodide, which consists of 1 atom of zinc and 2 iodine atoms. The atoms are conserved. Now let's go to the periodic table and look at the relative atomic masses of zinc and iodine. The relative atomic mass of zinc is 65,4 and iodine is 126,9. If we add the mass of the reactant atoms, 65,4 plus 2 times 126, the total mass of the reactants is 319,2. Now, if we add the relative atomic masses of each atom found in a particle of zinc chloride, the total mass of the product is also 319,2. Can you see that the mass is conserved during a chemical reaction? Try to do the same thing for the reaction between sodium and chlorine. The relative atomic mass of a sodium atom is 23 and the relative atomic mass of chlorine is 35,45. The balanced chemical equation for the reaction tells us that 2 sodium atoms react with 1 chlorine molecule, which is diatomic and consists of 2 atoms, and forms 2 units of sodium chloride. Show that matter is conserved in this reaction by calculating the total mass of reactants and the total mass of the products. The total mass of the reactant atoms is 116,9, and so is the total mass of product atoms. The balanced chemical equation reflects the conservation of mass. A balanced chemical equation is central to all quantitative studies in chemistry, which you will learn about later in the year. That's why this skill is so important. You will need to interpret the balanced chemical equation for the reaction of aluminium and iodine in the task video on representing chemical change, and visit the Mindset website www.mindset.co.za/learn. That is the end of this series of representing chemical change. By now, you should be able to balance chemical equations. Goodbye.